Hello everyone, this is Rui PCB, your trusted PCB partner. Today our topic is differential pair setup and routing matching techniques. In the previous session, we already understood the principles and advantages of differential signals. Today we will put theory into practice by learning how to set the correct rules for differential pairs and mastering key routing techniques to ensure complete signal transmission. First, this is still the previous circuit. I have deleted a set of differential lines which I will use in a moment to demonstrate how we do the routing. So how do we set up a differential pair? There are several methods. One of the most effective methods for managing these complex design elements is by utilizing the dedicated differential pair manager. Let's take a more detailed look. Here, this is the differential pair manager. You can see that many differential pairs have already been set up here, each with a name and a net assigned. This is one way to do it. Another way is to directly select the differential pair during routing. For example, when routing, you can choose to place a differential pair. Wait, not that. During routing, select the differential pair. Once you've selected the differential pair, you can use it directly. Let me also try one that hasn't been set as a differential pair. When you know these two traces are differential pairs, let's assume they are, when you click the first one, it will prompt you that it hasn't been set. Then after you click confirm, it will add the first one, and then we select the second one. This is also a very simple way to set up a differential pair. I usually prefer this method because you don't need to set it up in advance. When you're routing and reach the differential pair, you just select it then. But the premise is that you drew the schematic yourself and you clearly know which traces are differential pairs, so you can set them up this way. Next, we also need to set some rules for the differential pairs. When we're setting up the design rules, there are also options for differential pairs here. For example, several default ones have already been set up here using the name USB, along with information like trace width, spacing, and so on. If you have a lot of differential pairs with different rules, such as various trace widths and spacings, you can configure them here yourself. But for now, I won't set them up here. Setting the correct combination of trace width and spacing is key to ensuring impedance matching for differential pairs, which is crucial for high-speed signal integrity and at least helps to reduce reflections. So for those with higher frequencies, you need to know how to set them up and also know what values to use. We can draw one to complete this differential pair since the differential pair has already been set up. You see, as long as I select one, it will automatically select the other. When routing, the spacing between them is always maintained throughout the process. And also we can see that next to the mouse cursor, the differential pair length error appears showing the current deviation and whether it meets the rules. The middle one means it meets the rules, the left means it's less than, and the right means it's greater than. Then we can finish routing this line according to the original circuit path. When this particular connection has one component with a jumper and another component without, the electrical connection is then fully complete. Then when it indicates that the rule is not met, including when you perform a DRC check, it will notify you that the rule is not met. So what should we do if the rule is not met? We need to adjust the trace length. How do we adjust the trace length? For example, this trace, usually the outer trace will be longer because it's easy to understand that when turning, the outer curve is always longer than the inner one. In this case, we can use the trace length tuning tool. Select the length tuning tool under routing, and then we can choose. For example, right now it shows that the length is compliant. If it's not compliant, we can select the trace like this, but in this position, the via will have an effect. We can use the method of drawing a serpentine trace, adding a serpentine pattern, background noise to adjust the trace length so that it meets the requirements. Of course, since this one is already compliant, I won't adjust it. I'm just demonstrating how to make the adjustment. Then as for consistent spacing, this is easy to handle. When routing, the EDA software automatically ensures consistent spacing. Another point is that the reference plane must be continuous. Differential pairs must always have a complete uninterrupted reference plane, either below or above them, which is usually the ground plane. we can take a look at this diagram. Its GND has very few traces running through it. Only those that absolutely cannot be routed elsewhere are placed on this plane. For the most part, it remains intact. So when our differential pair passes through this area, there will be a complete ground plane underneath it to reduce interference. Today, we learned how to define differential pairs in EDA, set their routing rules, and mastered key routing techniques for maintaining consistent trace length and spacing. Properly setting up and routing differential pairs is fundamental to ensuring stable performance in high-speed circuits and meeting EMI standards. I hope that through these two lessons you have gained a deeper understanding of differential signal distribution and can apply this knowledge in your actual projects. If you enjoyed this video, please subscribe to my channel for more content. Thank you all.